I'll introduce Mr. Frank Schubert to you all. Dr. Frank Schubert is the head of Airbus Cybersecurity, Defense, and Strategic Programs in Germany. Okay. Oh, I see. Fantastic. And Frank has graduated electrical engineering and information technology, was a member of scientific staff at the DLR in the past, and he joined Airbus at 2012. Okay, so we will start our session. Our fireside chat. Noam, would you like to join us, or would you like to grab a mic? Thank you. Okay, so as you all understand, aviation is a very complicated ecosystem. Civil aviation, military aviation, and all together. Aviation, as mentioned, is living in a very complicated, fragmented ecosystem. And of course, the cyber risks are there while going through all the digital transformation and the system of systems and all highly connected and so on and so forth. So I have a few questions for you. Christoph, please. What kind of research is required to provide appropriate answers to face the challenges that we have talked about, of course, in light of the system of systems?
I think some of the bigger challenges are really the interoperability, since we'll see not only nations want to work together, but also industry. We will not be able to buy everything by one supplier, even if this would be desirable. But at least when we work international-wise, we need to think about interoperability. And that leads us to standards that has to be addressed, what we do since decades for military hardware, but even more important now for the software developments. And since we have some very advanced companies in Europe as well as in Israel, but also very protective national procurements, we will face some challenges that are beyond pure technology that will hamper us then and really work together in the environment, and also opens up vulnerabilities for our system that are operated and threat vectors as well.
Thank you very much, Christoph. Frank, would you like to add on that? About the kind of research required?
Yes, that's actually very true. So to bring the systems into operation, that requires like an orchestrated approach on different aspects. So Christoph, I liked your picture on FCAS very much, right? When you remember the screen, the graph where the systems were interconnected. We had like the new fighter, of course, there was a high altitude platform, there were like legacy fighters stations on the ground. And actually, to make this happen, this is a real challenge. I mean, this is the requirements of the future military scenarios that we will see, that the customers have, the MODs. But to make this happen, we need to move in many respects. So you also mentioned zero trust. That's, of course, one approach for the interconnection. Also, the secure connectivity is an aspect here. And so what we will see is the different life cycles of all these products. So they will overlap, right? We have the legacy systems, we have systems to be developed. We make sure that, of course, all operate secure for themselves with a product security lifecycle process. Still, they need to act together as one system of systems. And to make this happen, I would say the concepts are not there yet. So here's a lot of research required in coordination with the accreditation authorities. So we can probably fulfill technically the requirements the MODs have, but then to get accreditation for that, that will be a challenge. But luckily, there's time, of course. I mean, until FCAS will fly, it's still some years to go. 2030, 2040 maybe, we will see. So yeah, but the time is now to start actually the cooperation to bring up concepts like information-centric data processing, zero trust networks, including wireless secure connectivity among many platforms. So you're completely right. I agree. Yeah.
Thank you. I would like to add that, and we will touch it later on. But in civil aviation, well, we all are very used to the technology transformation in the IT world, where everything is connected, everything is mobile, everything is changed very fast. A lot of applications. In the aviation, it's quite different. And here we have a few challenges. We will touch it a bit later. Just for you to know, we are going through kind of a risk assessment to enable the aircrafts to understand where are the cyber risks there. And an E-enabled aircraft is, talking mainly about civil aviation, is mainly it's kind of a flying data center, but very different from the IT world still. Noam, would you like to add?
Yes. Here? Okay. First of all, I want to thank you. I want to thank you all. Of course, it's a great pleasure. I didn't present myself yet, although Daddy tried. I'm from IALTA. I'm the CRO, Chief Revenue Officer. I'm with IAI now for 3.5 years. And before that, I worked with Daddy at the INCD. And it's very good to be here again from the other side of the... Now, regarding your question, sir, and regarding life cycle, the problematic life cycle and the combination between the high vulnerability on one hand and the high importance to human lives and operational continuity that some of our colleagues just mentioned. I think that the magic word from our side, at least, is hybrid and cooperation, two magic words. And what we are doing and trying to deal with the challenges of the R&D on one hand, and the already needed cybersecurity and cyber defense or protection, whatever, is that we combine. For example, we established what we call the IACCC, the Israeli Cyber Aviation Companies Consortium, based on our experience with the ICCC that deals with solutions, already existing solutions for the ecosystem, because the threat is already here. And on the second thing is the R&D effort. And for example, we established a daughter company that we call Aviation, and we have something that we call SciLab, the idea of cybersecurity labs. And this is the idea of cooperation. As Una said, we won the tender for smart mobility cyber lab for the Israeli government. But today we also offer it to other governments because we understand the challenge is so huge and the life cycle is so problematic. And of course we have our own advantage because we have planes, because we are aerospace industry, but it's much more complex than this. So we believe in what we call the model of sister labs, that we're going to have designated, let's call it R&D centers that are cooperating between themselves. And we are doing it in the smart mobility world, at least we are trying to do it. And this will help this combination, this hybrid model, this cooperation between the government and the industry, between different governments and companies, between different academic institutes or research institutes, will allow us to solve the problem, to meet with this, to mitigate the problem, this huge problem of bad guys, vulnerabilities, and the life cycle.
Yes, please, Danny.
I have a question to the three of you, and I want to take this one step further. And my question is regarding research infrastructure. Mr. Kennan from the Ministry of Interior speak about quantum key distribution, the quantum encryption and everything. And of course about artificial intelligence. That's, for that we need high performance computing. This infrastructure costs a lot. We have the academy, we have the industry, we have the military. Where should we build our research infrastructure that will serve everyone? Thank you.
Christoph, to you maybe?
Would be happy to. I think the question where to build is hard to answer. I think this will be always some kind of a national issue. But I think the point that Noam made earlier is the most important thing here. If you have those high expensive infrastructure we need, we have the responsibility also to share it with industry, with government, with other stakeholders, made national-wise or international-wise. And this is, I think, where in parts we lack this in Germany, that we are somehow also forced to work together with the good colleagues, Frank from Airbus, German Aerospace Center, and then also military authorities to work together to use, for instance, the infrastructure, the research infrastructure, including high power computation center, including the labs for quantum mechanics, including satellite infrastructure for quantum key distribution, and so on and so forth. So this is available for research, but then also to get the technology then transferred to the industry, then they can provide it to the customer. I think this is something we have to get better in Germany in general, to get those three together and work on the same platforms, on the same research infrastructure.
You know, Danny, I think it's a wonderful question, and again, I think that we can't, the threats and the challenges are so huge that we need to understand that we can't solve it alone. Not the industry, not the government. We're still liberal countries, you know, and the price is enormous, And I think that the cooperation between the different pillars inside the countries and between the countries. And again, we are trying to do it because, for example, with the smart mobility is very close. Let's call it's a family. And the Israeli government, the INCD, and the Ministry of Transportation are investing money because we can't do it alone. But we need, let's call it an economic base. And again, even in the industry itself, we as IAI, we are a huge company. We don't have the solutions for everything. So we involve, and we have partners, we're full partnership with startups, with international companies, because we can't solve it alone. And again, one of our lessons learned is that one lab is not enough. We need to establish, let's call it a network. This is the cyber world, so a network of labs that are going to cooperate between themselves with the academy. And for example, high-level computing or supercomputing, whatever, it's the best example because the infrastructure is so expensive that no one can afford it by itself. But the knowledge be for the use of all, of everyone. Otherwise, we're going to miss it. Otherwise, you know, one of my colleagues mentioned this, the supply chain. And today, in the last, 18 months, we are living in a new kind of problems in the supply chain. We are familiar with it. We can't solve it alone. The vendors are vulnerable. We need to cooperate to solve the problem. And this network, this infrastructure, this the needed international infrastructure, without it, we can't solve it.
Okay, so we have...
That's right. In addition, of course, industry is protecting the platforms, components, encryption using post-quantum methods, but it's really hard to find the experts there, right? So it, in the end, again, boils down to education and what happened like many years ago when like programming languages were sometimes often first introduced in universities. So students just started working with it, Java, for example, many years ago. And since the post-quantum world and the work with quantum algorithms is fundamentally different from what we all know, this is actually the place where we should tackle the problem. Bring these new concepts into the schools, into the universities, like make quantum computers available in the cloud over the internet so that students can work with it and start developing algorithms. This will help our society drastically in a few years from now.
Yes, thank you very much, Frank, for that. Next topic, the aviation industry. I would like to talk about the aviation industry, the civil aviation industry mainly, but the military as well. It's a quite traditional industry. Definitely regarding everything regarding safety, which safety comes first, and security, which is two different things, safety and security. And the certification cycles in civil aviation, at least, are very, very long, with a lot of standards from EASA, from FAA, from ICAO, and this takes a lot of time. Now, maybe Frank, for you first, what are the required changes to the traditional approach in order to cope with the dynamic and agile nature of, I would say, IT-oriented cybersecurity challenges?
Yeah, so what industry requires here is clear guidelines. And traditionally, you're right, aviation is a field that moves rather slowly. Still, we are seeing good progress here. So safety standards like the CS25 are currently being amended with security aspects, and this helps industry very much. So, of course, then it's also not a discussion anymore if and how cyber security needs to be brought into the design phases of components of platforms. But it's a requirement in the end. So having those aspects in standards helps everyone, the customers, industry, to be able to create secure platforms in the future.
No.
Well, I have to say that we see it as a, let's call it a double challenge for both. For the industry itself, we need to fit our solutions, I would say, not to be too complicated, too challenging, because otherwise we were not going to solve the problem. The best example, I had a discussion with Tamir that sits in the audience a few months ago. What we expect our systems to do, only to monitor or even to mitigate with the threat in real time. We need to keep in mind that, let's call it the unique problems or unique characters of the aviation. This is one thing. The second thing is the regulation. My colleague here said that we need to have a guidelines. I think that we need to have let's call it a discussion regarding the capabilities and regulation. We need, it's a mutual influence. If only one side will going to come to the table and say, hey, this is the solution. On the other hand, these are the regulations, we're going to fail. We need to mutually influence each other. Otherwise, we can't solve it. Otherwise, the life cycle, the long life cycle, the vulnerabilities, the problems, it's very easy to kill these solutions when they're young, but we don't need, it will be disaster. We need to influence each other. On one hand, and we in the industry, we need to keep in mind a few things. First is our limitations. Second are the limitations of this sector. And third is that we need to fit and to mitigate the relevant reference threat. Otherwise, we can bring to the table a high-end solution. It's going to be too expensive. No one will invest in it, and it will never will pass the regulation. So we need to speak with each other and to fight together. The industry, the cyber industry, the aviation industry, the cyber industry, and the regulators together to find a solution. Otherwise, we're gonna fail.
Yes, thank you, Noam. Definitely, when we talk today, the whole high-tech industry, the software industry, we talk about being agile with high speed of releases, software releases, fixing vulnerabilities. Vulnerabilities is quite hard today, right? When the airplanes become more and more digital ones with high connected communication to support new features, that's a real challenge, I think. And the question is, how can aviation industry adopt innovative technologies, new technologies, to make traditional communication protocols more safe and secure? Christoph, would you like to answer that? He's not there. So Frank, please take charge.
Yes, so you are right. Planes, the whole aviation industry, also airports are examples for cyber-physical systems. And especially connectivity is a key point here, secure connectivity. So what we've seen in the past is that currently also there's a digitalization ongoing. So the radio communication between the planes from the air to the ground is being digitalized currently. And connecting this to our earlier discussion, thinking there of algorithms that are post-quantum safe is a key factor. And I think this is a field where the research is currently heading. Also, looking at the system of systems approach that we had in the military context, it can be well applied to the civil world, right? Then the whole aviation industry has to is connecting systems in the end. Also, an airport is a system of systems. We have access control doors, we have baggage handling, we have flight operations, and most of those systems are connected with each other, sometimes with the internet, to provide information to the customers, right? And to handle this in a secure way is a challenge. Also, whenever new aspects are being introduced, think of baggage pickup at your doorstep. Think of contactless boarding with your Face ID. All this leads to an increase of attacks. To be able to find those attacks that happen in the physical world and have a combination with the cyber world, that's really a challenge. Think of spoofing when we are thinking of secure communication. If radio links are being spoofed, or if there's a counterfeited signal, and at the same time someone is starting a cyber attack, currently to detect those kind of hybrid attacks is really a challenge. And I'm happy that there's research ongoing. For example, in the SATI project, that's taking care of exactly those threats at airports, developing new secure operation centers that are being demonstrated in the future in 3 airports: Zagreb, Milan, Athens. As DLR is involved there, is heading the project, Airbus cybersecurity is contributing with the correlation engine to be able to detect combined attacks from the physical world and the cyber world. So this is the future we need to go, and there's actually research going on for cyber-physical systems, including secure communications.
Yeah, and talking about these risks, let's now talk about the threat model. What is the threat reference?
Again, Tamir sits with us at the audience, sitting with us at the audience. Or I think it was 4 months ago. Tamir asked me about a very similar question, and my answer was that we are in the middle of arm race, if you remember, and we are in a huge arm race, and I'm not sure that we are winning it. But I think this is a hybrid arm race, and I think that we have numerous examples for it. On one hand, we can see the commercial, let's call it. It's funny to call it commercial, but I'm going to use this term, commercial threat. Guys who are trying to penetrate systems, that are using ransomwares and other stuff. And this is, let's call it the low level, although some of it is very complex. Threats. On the other hand, we can find what I usually use the term, the superpower threats. And we need to combine or to mitigate with both of them, although it's very important, very problematic, very expensive. Now, again, a few minutes ago, I said that we need to deal with the ecosystem. And again, regarding the last question that you asked Gadi, the connectivity problem is, we're all aware of it, and we need to deal with the ecosystem. Now, to deal with the ecosystem, mainly, let's call it, can solve the problems of the commercial threats. This is a wonderful thing, and it's going to give us a high level of resilience, but it's not going to solve the real, or at least the high-end the problem of the high-end threats. And we need to combine it, at least for some of the targets. We need to deal with the high level, or at least the national level threats, because we can see it. We can see in the last 2 years, we saw more and more, and we can see more and more attacks against critical infrastructure, attacks against the healthcare sector, whatever, secrets, targets that no one dealt with them till a few years ago are now considered to be legitimate targets. So we need to be focused on both sides. Otherwise, we're going to leave the targets or the sector exposed. Now, of course, this is very problematic, and regarding
No, sorry for disruption. We have the Minister of Science and Technology.
Oh, Ben.
Hello, everybody. Good morning. It is my pleasure to say a few words on this important Cyber and Innovation Week as the Ministry of Innovation, Science and Technology of the State of Israel. I would like to open by expressing on behalf of the government of Israel and the people of Israel my deep condolences to our German friends over the devastating floodings last week. And as you know, Israel is an eternal friend of Germany, and we are ready to help you as much as they needed. The relationship and the science and technology and innovation cooperation with the state of Germany is very strong and is very strategic to our two countries. And it is an important collaboration that we are committed to prolonging. I was very happy to meet with President Steinmeier a few weeks ago in his visit to Israel. We discussed, among other things, the different collaborations in areas of science and technology and high technology. And we talked about setting up a visit in Germany in the future, in the coming future, in order to deepen and even strengthen more the collaboration of the two states. This kind of collaborations in areas of innovation and technology is important not only to the two countries, but as we all know, that technology and innovation is the way of making the world a better place. And so I see such cooperation as a vital to our future and to the relationship of the countries. So I'm wishing you a successful event, and I say thank you to the Helmholtz Association of the German Research Center. Wish you all a fruitful day and much success today. Thank you.
Thank you very much, Minister Farkash-HaCohen.
Thank you.
Now, Daddy, you can continue.
Thank you very much. Yeah, sure. So just to conclude, so thank you very much to Frank Schubert, and to Noam Krakover and to Christoph Müller for your contribution to the panel. And now we continue. Thank you.
Pleasure. Thanks for having me.